What if the universe made a mistake? Not a small one. Not the kind that gets quietly corrected in the next edition of a textbook. A real mistake, the kind that makes physicists sit back from their keyboards at 2 in the morning and stare at the ceiling, genuinely unsure what they're looking at. There is something sitting at the edge of the observable universe, 10.4 billion light-years away. It doesn't move. It doesn't announce itself. It has no interest in being understood. And it is so large, so almost grotesquely large, that some of the people who study it professionally have admitted, in published papers, that they aren't entirely sure how it got that way. Its name is TON 618. And the longer you sit with what it actually is, the quieter everything else gets. I remember the first time I really tried to picture it. Not the number is easy to say, but the actual physical reality of it. I was reading through a summary of a 2021 astrophysics paper, late at night, and I kept stopping at the same line. 66 billion solar masses. 66 billion times the mass of our sun. And I thought, that can't be right. Something in the human brain resists that figure. That's not a failure of imagination. That's actually what makes TON 618 so philosophically strange. It exists at a scale where our intuition simply stops working. We evolved to understand things we can touch, things we can see across a room, threats we can run from. We did not evolve to understand an object whose gravitational boundary, called the Schwarzschild radius, stretches roughly 1,300 times the distance from our Sun to Pluto. Our entire solar system would fit inside TON 618's event horizon, with room to spare. To understand what TON 618 is, you have to understand what a quasar is. And to understand a quasar, you have to go back to the early universe, to a time so distant that the light reaching us now left its source before the Earth existed. Before the Sun existed. Before most of the stars you see on a clear night in rural Montana had even begun to form. In the first few billion years after the Big Bang, the universe was a very different place. Denser. Hotter. Full of gas clouds collapsing under their own gravity into the first galaxies. At the centers of many of these early galaxies, something extraordinary was happening. Supermassive black holes were feeding, pulling in enormous quantities of surrounding material, gas and dust and whole star systems, at rates we almost never see in the modern universe. When a black hole feeds aggressively, the material doesn't fall in quietly. It forms a structure called an accretion disk, a vast, swirling mass of superheated gas orbiting the black hole before eventually crossing the event horizon. This disk gets so hot, compressed so intensely by gravity and friction, that it radiates more energy than an entire galaxy of stars. Sometimes much more. In the most extreme cases, it produces jets of plasma shooting outward at close to the speed of light, extending for millions of light-years in either direction. This is what a quasar is. A feeding supermassive black hole so energetic that it outshines everything around it by orders of magnitude. From across the universe, it looks like a single point of impossibly bright light. Early astronomers, discovering them in the 1960s, called them quasi-stellar objects, because that's what they looked like. Except they weren't stars. They were entire black holes, billions of times the mass of our Sun, actively consuming their surroundings. TON 618 was one of these. It was discovered, or rather, recognized for what it was, in 1957 during a survey of the sky. The designation TON stands for Tonantzintla, the Mexican observatory whose catalog first recorded it. 4 years it was simply noted as an unusual blue object. It wasn't until later analysis, particularly work done in the 1970s and confirmed with increasingly precise instruments since, that astronomers understood they were looking at one of the most luminous objects ever observed. At its peak, when the quasar was active, TON 618 was radiating energy at roughly 140 trillion times the luminosity of our Sun. If you placed it where our Sun is right now, the night sky as we know it would cease to exist. There would be no night. But here's what makes this stranger still. That light, the light we are detecting now, the light that our instruments have been analyzing, left TON 618 10.4 billion years ago. What we're seeing is not TON 618 as it is. It is TON 618 as it was, when the universe was less than a quarter of its current age. We are looking into the past. Every time we point a telescope at it, every image, every data point, every measurement is a message from a universe that no longer exists in that form. Whatever TON 618 looks like right now, in this moment, in our present, we have no idea. That information hasn't reached us yet. It won't reach us for billions of years. By the time it does, there will be no one left to receive it. The mass is where things get genuinely unsettling. Not theatrically unsettling, not in a way that's designed to make you grip your armrests. Quietly unsettling. The kind that settles in slowly after you've had time to think about it. 66 billion solar masses. Our Sun weighs approximately 2 times 10 to the power of 30 kilograms. To get the mass of TON 618, you multiply that by 66 billion. The number that results is not a number the human mind can picture. It is a number that exists only on paper, only in equations, only as a symbol that stands in for something fundamentally beyond our perceptual reach. To try to make it concrete, our entire Milky Way galaxy, with its 400 billion stars, its dark matter halo, its spiral arms stretching 100,000 light-years across, has a central black hole called Sagittarius A. Sagittarius A has a mass of about 4 million solar masses. That's our black hole. The one at the center of everything we call home. TON 618 is 16,500 times more massive than Sagittarius A. It is not a bigger version of what we have. It is a different category of thing entirely. The question that keeps astrophysicists up at night, and I mean this almost literally, I've read interviews with researchers who describe returning to this problem the way you return to a nagging thought you can't place, is how did TON 618 get so large, so fast? Black holes grow by consuming mass. That's straightforward, but there are limits. When a black hole feeds very aggressively, the radiation from its accretion disk pushes back against the incoming material. This is called the Eddington limit, the theoretical maximum rate at which a black hole can grow before its own energy output begins to halt its own feeding. It's a natural break on the system. TON 618 appears to have grown to 66 billion solar masses in less than a billion years after the Big Bang. By standard models of black hole growth, operating at or below the Eddington limit, that's extremely difficult to account for. You would need a very large seed black hole to start with, perhaps itself the result of the direct collapse of an enormous primordial gas cloud, bypassing the star formation stage entirely, and then sustained feeding at or near the maximum possible rate, with very few interruptions, for hundreds of millions of years. It's possible. Physics doesn't forbid it. But it requires conditions that were specific, sustained, and in some ways improbable. And that raises a question that astronomy hasn't fully answered. Was TON 618 an accident, or was the early universe routinely producing objects like this, objects we simply don't have enough data to account for yet? In 2023 and into 2024 and 2025, the James Webb Space Telescope began finding early universe galaxies that were far more developed than expected, galaxies that appear to have formed stars at rates our models struggle to explain. The data is still being analyzed, The models are being revised. It's one of those moments in science where the instruments have outrun the theory, and the theorists are running to catch up. TUN 618 sits at the edge of that same question. It is not an anomaly to be dismissed. It is an anomaly to be understood. And we are not there yet. There is a concept in physics called spaghettification. It sounds almost whimsical, like something from a children's science book, but the reality it describes is not. When an object approaches the event horizon of a black hole, the gravitational pull on the side of the object closest to the black hole is significantly stronger than the pull on the far side. This difference, this tidal force, stretches the object vertically into a long, thin strand, like pasta being pulled. For a stellar mass black hole, the small ones, a few times the mass of our Sun, this process would begin well outside the event horizon. You would be torn apart before you crossed it. But for an ultramassive black hole like TON 618, something counterintuitive happens. Because the event horizon is so enormous, so incomprehensibly large, the tidal forces at the boundary itself are actually relatively gentle. You could, in theory, cross the event horizon of TON 618 without feeling anything unusual, without noticing the moment of crossing. The gravity at that boundary, while immense in absolute terms, is spread across such a vast distance that the difference between the pull on your head and your feet would be survivable. At least initially. You would simply be inside. And you would not know it. There would be no wall. No visible boundary. No alarm. Just inside. In a region of space from which no information can escape. From which you cannot escape. Moving forward through what would feel like normal space, but a space that has, in the language of general relativity, been so curved by gravity that all paths, every possible direction you could move, including the direction of time itself, lead inward. There is something philosophically devastating about that. The idea that a threshold so final, so absolute, could be crossed without ceremony. That the universe does not mark its most extreme boundaries with warning signs. That the most consequential moment imaginable could feel, from the inside, like nothing at all. When I look at what we know about TON 618, I keep coming back to the question of scale, not just physical scale, but temporal scale. How do you relate to something that has existed, in some form, for the better part of the universe's history? The universe is approximately 13.8 billion years old. TON 618 formed within the first billion years of that history, which means it has been sitting there, in whatever form it currently takes, dormant now that its active quasar phase has long since ended, for something in the neighborhood of 12 to 13 billion years. 12 to 13 billion years ago, the Earth did not exist. The Sun did not exist. The region of the Milky Way where our solar system would eventually form was empty space, not yet gathered into stars. Life on Earth, all of it, from the first single-celled organisms in ancient oceans to every creature that has ever walked or swum or flown, represents less than 500 million years of history. The dinosaurs, which we think of as ancient, went extinct 6 to 6 million years ago. That's not even a rounding error in TON 618's timeline. And yet here we are. A species that has existed for perhaps 300,000 years, living on a planet that formed 4.5 billion years ago, in a galaxy that's been around for about 13 billion years, looking at something that has been sitting in the dark since before any of it began, and asking, with real earnestness, what is that? There's something almost tender about that. The audacity of it. The nerve of this small, warm-blooded, briefly living species to point instruments at the edge of everything and insist on understanding. One of the things that gets lost in popular science communication is the honest uncertainty. the places where the maps run out. We talk about TON 618's mass as if it's a settled figure, and in one sense it is. The measurements have been made, the calculations checked. But the mechanism of its formation, the full picture of what the early universe looked like, the question of whether there are objects even larger that we simply haven't detected yet, these are open. Genuinely open. The observable universe is a sphere approximately 93 billion light-years in diameter. We can only see what's within that boundary, the region from which light has had time to reach us since the Big Bang. Beyond it, there is more universe. Almost certainly vastly more. And within the observable universe, we have not catalogued everything. Not even close. TON 618 is currently the most massive black hole with a directly and reliably confirmed mass measurement. But it wasn't always that record holder, and that record has been challenged before. In the last few years, surveys with increasingly sensitive instruments, including ongoing work with the Very Large Telescope in Chile, the Event Horizon Telescope collaboration, and space observatories, have been turning up candidates that may rival or exceed it. What this tells us is not that the record doesn't matter. What it tells us is that the universe is more extreme than our current snapshot of it. We are always working from incomplete data. Every conclusion in astronomy is provisional, held lightly, subject to the next observation. That's not a weakness of science. That's its defining feature. The willingness to say, this is our best understanding, and we remain open to being wrong. The philosopher Blaise Pascal wrote in the 17th century, sitting in France, looking up at the same night sky you've looked up at, with none of the tools we have now, that the eternal silence of infinite spaces frightened him. Le silence éternel de ces spaces infinis m'effraie. He felt it intuitively, through pure reason and geometry, without ever knowing what a black hole was, without knowing that galaxies existed, without knowing that the light he saw had traveled for years to reach his eyes. He was right. And he was also somehow understating it. Because the silence of TON 618 is not just spatial. It is temporal. It is the silence of something that has outlasted almost everything in the universe and will outlast almost everything still to come. Black holes, according to our current understanding of physics, don't simply disappear when the universe grows cold and dark. They evaporate, slowly, through a process called Hawking radiation, the gradual emission of quantum particles at the event horizon, predicted theoretically by Stephen Hawking in 1974 and still not directly confirmed by experiment, but broadly accepted by physicists as almost certainly real. For a black hole like TON 618, the evaporation timescale is almost beyond any number we can write meaningfully. Estimates place it at something in the range of 10 to the power of 100 years. A Google years. To put that in context, the current age of the universe is about 10 to the power of 10 years. TON 618 will still be there, still evaporating, still enormous, long after the last star has burned out, long after the last proton has decayed, long after every other structure in the universe has dissolved into a cold, uniform fog of particles barely above absolute zero. There is a version of the future in which TON 618 is one of the last things left. I want to stay with that for a moment, because I think it does something to a person, or it does something to me, anyway, to genuinely sit with the idea that there are structures in this universe that will outlast everything we have ever known or loved or feared or built. Every civilization in human history, every war, every book, every song that made someone cry in a car on a Tuesday evening in November, every prayer ever whispered in a dark room, every moment of grief and every moment of unexpected joy, every species that went extinct before we named it, every star visible in the night sky tonight, all of it, will be gone, completely and irreversibly gone, while TON 618 continues to exist. And somehow, I don't find that depressing. Or not only depressing. There's something else in it. Something closer to perspective. The kind that can only come from outside the human story entirely. Your problems are real. The thing that kept you awake last night, the thing you're worried about, the conversation you're replaying, that's real. Human pain is real. Human worry is real. But it is happening inside a very, very small frame. And the frame extends in all directions, in all of time, into distances and durations that make even our greatest catastrophes look brief and local. That's not meant to diminish anything you're feeling. I think it's actually meant to do the opposite. To give it context. To say, you are carrying something real, and you are carrying it on a planet spinning through a galaxy among hundreds of billions of galaxies in a universe that contains objects like TON 618. And you are still here, still watching, still curious. That's not small. That's remarkable. The fact that TON 618 is currently inactive as a quasar raises its own quiet questions. At some point, perhaps 6 to 8 billion years ago, as the surrounding gas and material became depleted, the feeding slowed. The accretion disk thinned and faded. The jets quieted. The extraordinary luminosity that would have made it the brightest point in any nearby sky dimmed and eventually disappeared from our ability to detect it. What's left is what astronomers call a dead or dormant quasar. The black hole remains. The mass remains. But the dramatic activity is over. There is no accretion disk blazing at millions of degrees. There is no jet of plasma screaming outward at relativistic speeds. There is just the gravity. Just the curvature of space-time. Just this enormous, ancient, silent distortion in the fabric of the universe, sitting there in the center of its host galaxy. The galaxy itself, the one that TON 618 inhabits, is not well characterized. We know it exists. We can infer its presence from the quasar's behavior and from surrounding light. But the quasar was so overwhelmingly bright during its active phase that it drowned out everything nearby. In a sense, the black hole was so dramatic that we never got a clear look at the galaxy around it. The supporting cast was invisible because the lead was too bright. Now that the quasar has faded, we might eventually get a clearer picture. But this is complicated by the distance. 10.4 billion light-years is not a distance we can resolve with precision. What we see is always blurred by time. One of the most philosophically strange things about studying objects at cosmological distances is that you are not really studying one thing. You are studying a relationship. A relationship between an object and light, between light and time, between time and the expanding fabric of space itself. The universe is expanding. And it has been expanding since the Big Bang. Which means that the space between us and TON 618 has been growing, and is still growing, at a rate that actually exceeds the speed of light at those distances. Not because anything is moving faster than light through space, but because space itself is expanding. The light that left TON 618 10.4 billion years ago has been traveling through an expanding universe. The distance it has covered is not the distance to where TON 618 is now, because TON 618 has been moving away from us, carried by cosmic expansion, for the entire duration of that journey. Where is TON 618 now? Right now, in our present moment? It is farther. Much farther. Perhaps 28 to 30 billion light-years away, depending on how expansion has proceeded. That information, that light, is currently in transit. Billions of years of travel ahead of it. It will never reach us. Because the space between us is expanding too fast for light to cross it. TON 618's present is unreachable. We will only ever know it as it was. A fixed portrait from the ancient past. There is a concept that comes up in discussions of very large black holes that I find quietly haunting. It's called the photon sphere. At a certain distance from a black hole, outside the event horizon, but still within the strongest region of its gravitational influence, the gravity is so intense that photons of light can travel in a perfect circle. They orbit the black hole. They don't fall in. They don't escape. They just orbit. Endlessly. For TON 618, the photon sphere is located at a distance from the center that, in other contexts, we would call interstellar. If you were standing at some safe observational distance and watching, you would see the black hole surrounded by a bright ring, a halo of light that has been trapped there, circling, for potentially millions or billions of years. Light that left some distant star long ago, bent into orbit by the gravity of this thing, going nowhere, arriving nowhere. Trapped light is a strange concept. We think of light as the fastest, freest thing in the universe. Nothing outruns it. Nothing holds it. And yet TON 618 holds it. In a loop. Going nowhere forever. When I read about this, I thought of all the times I felt stuck in a loop of my own. Replaying something, circling a problem, unable to escape or resolve. And I thought, even light does this. Even the most fundamental, fastest, freest thing in the universe can find itself caught, circling, at the edge of something too large to escape. There's no shame in that. There's company in it, strangely enough. Let's talk for a moment about what we cannot know. Not as a rhetorical device, but as an honest accounting. We don't know what's inside a black hole. We have mathematics, the equations of general relativity, that describe the geometry of spacetime inside an event horizon. They predict a singularity at the center, a point of infinite density, infinite curvature. But physicists broadly believe that this singularity is a sign that the equations have broken down, not that a physical infinity actually exists. The singularity is a placeholder for our ignorance. Something happens at the center of a black hole that our current theories cannot describe. Quantum mechanics, which governs the behavior of particles at the smallest scales, and general relativity, which governs the behavior of gravity at the largest scales, are not compatible in their current forms. They don't work together. When you try to apply both simultaneously, as you would need to do at the center of a black hole where density is extreme and scales are tiny, the math breaks. You get nonsense. The two best theories of physical reality we have ever produced simply do not agree in that regime. Reconciling them, building what physicists call a theory of quantum gravity, is perhaps the central unsolved problem of theoretical physics. String theory, loop quantum gravity, and other approaches have been proposed. None has been experimentally confirmed. None has produced a universally accepted picture of what happens at the center of a black hole. So at the center of TON 618, at the center of the largest confirmed object of its kind, there is, in a very real sense, not a known answer. There is a question. A gap in our understanding of physical reality so profound that our two best theories of the universe, combined, cannot close it. We named it. We measured it. We do not understand it. The Event Horizon Telescope collaboration, which produced the first actual image of a black hole's shadow in 2019, the famous blurry orange ring of M87, has been developing the capacity to image more distant and larger objects. M87, the black hole at the center of the Messier 87 galaxy, has a mass of about 6.5 billion solar masses. 10 times less massive than TON 618, but significantly closer to us, at about 53 million light-years. TON 618 is nearly 200 times farther away. Direct imaging at the resolution required to see its shadow, what's called the apparent angular size, is currently beyond our capabilities. The apparent size of TON 618's shadow on the sky, despite the physical object being vastly larger, is actually quite small because of the distance. It's like trying to see a dinner plate from 1,000 miles away. But the next generation of instruments, the NEHT, the Next Generation Event Horizon Telescope, which as of 2026 is in development with plans for extended baselines and potentially space-based components, may change that. We have imaged one black hole. We will image more. The question of whether we will ever image TON 618 directly is open. But it is not obviously impossible. There is something I find deeply moving about that. The fact that a species that emerged on a small planet, that has only had writing for about 5,000 years, that only discovered the existence of other galaxies 100 years ago, is currently building instruments to photograph the largest confirmed black hole in the observable universe. That's not nothing. That's one of the most extraordinary things any species has ever attempted. There's a thought experiment I keep returning to. Imagine, for a moment, that somewhere in the universe, not necessarily near us, not necessarily in our galaxy, there is another form of consciousness. Another species, or something we don't have a word for. And imagine that they have, as we have, developed the capacity to observe the universe, to build instruments, to measure light. They would find TON 618 too, or something like it. Any sufficiently advanced civilization anywhere in the observable universe, looking back far enough in time, would find these enormous early quasars. Because they are not a local feature. They are a feature of the early universe itself, of a period when conditions were right for this kind of extreme mass accumulation. And any civilization looking at TON 618 would face the same honest uncertainty we face. The same gap in the equations. The same inability to know what's inside, what happened at the singularity, how exactly it formed so fast. The universe does not give its answers away completely. It sets the same problems for everyone. There's something quietly comforting about that. Not the uncertainty, the universality of it. The fact that the mystery is not our limitation specifically. It is a property of the universe that it keeps this to itself. The physicist Richard Feynman once said that nature uses only the longest threads to weave her patterns, and each small piece reveals the organization of the whole. I've thought about that a lot in the context of black holes. Because a black hole is not just a local object. It is a thread that connects the Big Bang to the end of time. It forms in the earliest moments of cosmic structure. It will persist through the death of stars, the dissolution of galaxies, the fading of the last light in the universe. TON 618 is, in that sense, the whole story in one object. Beginning to, near, end. It was there when the universe was young and chaotic and hot. It was there when the first civilizations on Earth built monuments they thought would last forever. It is here now, while you listen to this, whatever is keeping you up or whatever is letting you rest. And it will be there, unchanged, enormous, patient, long after the sun has swelled into a red giant and swallowed the earth and the night sky has gone dark. It doesn't know we exist. It has no awareness, no intention, no preference. It is not waiting for us. It is not indifferent to us in the way a person can be indifferent, with feeling, with choice. It is indifferent the way mathematics is indifferent. The way a law of physics is indifferent. It simply is, and has been, and will be. And we, briefly, improbably, are aware of it. There is a specific kind of feeling that I've come to associate with this kind of science. It's not quite awe, though it contains awe. It's not quite fear, though it contains that too. It's something closer to recalibration. The sense that the coordinates you were using for your life, for your worries, for your sense of what matters, they're not wrong. They're just small. And small isn't bad. Small is what we are. Small is what life is. A blade of grass doesn't need to be the size of a redwood to matter. A human life doesn't need to register on a cosmological scale to be worth living. The fact that TON 618 will outlast everything we've ever done is not an argument against doing anything. If anything, it's the opposite. If the universe is this vast, if time is this deep, if the structures in it are this extreme, then what a strange and specific thing it is to be alive at all. To be conscious. To have a moment of noticing. That moment doesn't have to be permanent to be real. You don't have to last forever to have mattered. The last thing I'll say about TON 618, at least for tonight, is this: it was discovered by cataloging the sky. By someone pointing an instrument at a patch of night and recording what was there. Systematically. Patiently. Without knowing what they'd find. A lot of the most profound things we know were found that way. Not by looking for something specific, but by looking. By being willing to catalog the unknown in the hope that it would eventually say something back. There's a patience in that. An acceptance that the answers come on their own timeline, not ours. That the universe is under no obligation to reveal itself quickly. That some questions will outlast the people who first asked them. That the work still matters, even so. 10.4 billion light-years away, there is an object 66 billion times the mass of our sun. It has been sitting in the dark for most of the history of everything. It will continue sitting there, long after the last light goes out. It doesn't know we found it. But we did. And somehow that feels important,